Hi, welcome to the 6502 show. Today, I got something really special for you guys. But first, I want to give you a quick update on Focal 65. The work on the source code is continuing. There are several people working on this, including myself, and we hope to have it all done and machine readable and ready to be proofread by the end of the year. So stay tuned for that. We've got some special stuff coming up. Now, on with a very special episode. Well, as you can see, this is the 6800 edition of the 6502 show, and it's so called because I wanted to tell you about a project I've been working on for the last 5 or 6 weeks, and that is building my own 6802 computer from scratch. From parts and a PC board and a schematic, and that's about it. I really wanted a challenge, and I wanted to do something I've never done before, and it was kind of outside of my comfort zone. But I got some inspiration from my acquaintance Gavin, who had built the GavDan computer, and we shared some ideas, and he looked over my schematics and said, "Hey, I think you can pull this off. Just be patient and check everything, solder carefully." So that's what I did, and I embarked on this journey. And I'm going to share some of that with you now. After a number of days of searching on the internet, I found this, the SBC 6800 by Mr. Suzuki Tetsuya. And this is an amazing piece of work. Beautifully documented, shows you the board layout, the board itself, where you can get it, parts lists, everything you'd want to have here, and how it's all put together and how you need to program it. Well, that's great, but I really don't read Japanese, so this wasn't going to help me, and as well, I couldn't order one because I didn't have a Japanese Yahoo account and credit card, oddly enough. Well, moving forward through the document, and we come to this, the schematic. Now, this I can understand. So as I'm going over the schematic by Mr. Suzuki, I noticed there's a PIC chip that is sending clock pulses up to the ACIA. And I thought, And then there's another one over there. So there's two of them. And one of them seems to be doing some addressing. So I thought, maybe there's a better way. Something a little more organic. Well, I then, through some more searches, figured out that this fellow, Ryuten, had made a 6802 version of Mr. Suzuki's design. I took a look at his schematics, and alright, same PIC controllers, but I noted the different wiring for the 6802 versus the 6800, and I thought, okay, I've learned something there. What else can I figure out? Then I had to address the baud rate generator for the 6850 ACIA, and I found this really cool design on, of course, a site called DigiCoolThings. He was using it on a 6809-based computer, but the principles are all the same. So I thought, I'm swiping that. I'm also thinking about, I'm taking little bits and pieces here and there, some ideas from Gavin, Jeff Tranter, I picked up a few ideas from him, and so that's how the computer got its name. It really is a Frankenstein's monster of ideas from here and there. It's mostly based on Mr. Suzuki's design, but it's got my own special little touches in it. So at this point, it was time to start drawing up my own schematic, and that's what I did. And of course, I had never really done anything this complicated before. Usually it's just something sketched on a piece of notebook paper because I've never really done anything this complicated. So I had to teach myself KiCad. Great program, a little fiddly, but it does everything you'd want it to do, and it wasn't too bad using it once I got the hang of it. I had my schematic. Well, now I needed to figure out well, where are things actually going to go physically on the board? So I did a physical layout, just rough sketched it out on a piece of paper. And then once I had that figured out, more or less, I got out the graph paper and did some actual placement, actual sizes, see where things would go. I'd say it ended up being about 90% right, but it was a great guide, especially when laying down the sockets and a lot of the passives. And from there, it was time to warm up the soldering iron. Well, the first thing I did was sock in a 40-pin right angle connector into the bottom of these cards. And then I put the sockets in for the ACIA and the MPU. So we've got top right is where the ACIA is going to go. The processor will go below that. And then I've got some control logic right there. That is a 74LS393 that's going to help us select the baud rate once we get that far. And then I finished up the RAM and ROM card there, and that's the one that's got the power on it. Our power chain is running up the right side there, and let's give it a test. Okay, let's give this thing a little power and see what she does. Success! And just to make sure, I'll put you right there, put you right there. We'll set this for 5 volts. Let's see what I have. Got, these are going, my rails are underneath, so I should have 5 volts. That is exactly what we have. And after every single component that I put on this board, I checked it just to make sure that everything was fine, and I tested everything for continuity or voltage or both, no matter what was going on. So I just installed this DIP switch. Let's make sure that my soldering was okay. So we go from the back of the switch here to pins 3 and 4 here, which will be our clock signals. Excellent. And not to the pin next door. Not to the pin next door. Whoa, to the pin next door. No, not to the pin next door. This is why you check. Then I finished up wiring all the control and logic for the ACIA and the MPU. You can see I've got a baud rate generator ready to go as soon as I dump in that 393 up there by the crystal canister. It will run from 19.2 kilobaud to 2400. So first switch there is 19.2, then 9600, then 4800, and then 2400. And of course you could set it up a little differently if you wanted. You know, that's the beauty of these things. They're pretty flexible. And so this is what it looked like when I was done wiring and soldering. This is the front of the HM68, and you can see the ZIF socket is in there with my ROM, and I got RAM below that, control logic, and in the back is the MPU and the ACIA. Now here's a look at the back of the wiring. Maybe it's not the prettiest thing you're going to see this week, but you know what? There isn't a short there. So now it's time to get to testing. Another tool I made was this little card that sat underneath the backplane and has all the pins identified. So it made it a lot easier to get to for testing, you know, when things were plugged into the card. So that helped a lot. Well, it was done, and I had myself a heavily modified copy of MicBug, and I had checked for power, I'd checked my clock, I'd checked my address lines, and I'd checked my data lines, and there was activity all over the place. But, as usual, things don't work out the way you want them to the first time around on something like this, and I was really grateful to have the help of the guys on the 6800 Homebrew Facebook group.
They were wonderful and helped me out of a couple of jams and answered some questions. I'm especially grateful to Sam and Doug and Chris. Chris, who talked me off a metaphorical ledge at one point while we were diagnosing some trouble on the serial port. But we got her done. And it turns out there were a couple of things that I'd neglected to do. I'd not connected the A14 line into my addressing, so had to solder that in. And the other thing was, in tracing everything down, I couldn't find anything wrong with my ACIA or my serial output. And it turns out this crappy little piece of stuff, it's a Max 232 that I got for $7, and it was worth every penny because it doesn't work worth a damn. So once I took that out and replaced it with a little PL2303TA, a USB to TTL cable. And from there, well,
I've written a little program that sits down in my EEPROM, and all it's going to do is on power up, it's going to print out the letter D from now to eternity. That way I know that my addressing's okay and that stuff's going through the bus to the ACIA and out to the terminal. Everything else seems to be right. So let's give it a go. Oh yeah.
It's alive! It's alive! It's alive! It's alive!
The next step was to burn a custom copy of MicBug into the EEPROM and then get that going and see what I would have there. All right, once more under the breech. Success! It's working!
okay, that's great. You got an asterisk. Wow. So what can you do with it?
The first thing to do was to get it a much better monitor. SWATbug by Southwest Technical Products is a step better than MicBug. It allows you to set breakpoints and do all kinds of fun things. You can go forward and backward in memory. It's pretty cool. Well, the main thing to do was to get this into a space in my EEPROM where it expects to be, and where all software expects MicBug and SWATbug to be, i.e. E1000. So I took the code and put it in there and changed the scratchpad addresses to 7F00. The very bottom of my RAM, it at least would take a lot less fiddling around if I've got standard I/O addresses. Then all I have to do is change any reference to the scratchpad. So that makes it a lot easier. First thing I want to show you guys is SWATbug. This is superior to MicBug because, well, it does a lot more things. There are breakpoints you can set. You can go backwards and forwards in memory. It also has the ability to call a disk operating system for a boot. And that's something I eventually want to do. I had to set the scratch memory for this to 7F00 because I have no RAM at A1000. But eventually, I will put 8K at A1000 through BFFF to handle flex. And so then I won't have to use a custom SWATbug any longer. But let's fire this thing up because other than SWATbug, one of the main things I wanted to do with the HM68 is learn 6800 assembly language. It's a rich instruction set. So I needed a really good monitor program, one with a good disassembler, the ability to move memory around, and again, set breakpoints, do lots of other things. Having a simple assembler was also important to me. And what ticked all my boxes was the TSC debugger. Let's take a quick look at that. And SWATbug is on. And I have remapped the Z key, Z. So instead of pointing to a prom that was used to sit at C1000, it now points to a little menu program I wrote. Uppercase is helpful. And there's my loader, and I can load the debugger. I've also got Micro Basic Plus and Tiny Basic on. But let's take a look at the debugger. All right, that fast. And the 2 asterisks tell me it's working. So if I wanted to, say, disassemble something, perhaps let's take a look at SWAT-bug. I could say disassemble E through, let's just look at E020. I get my disassembly. If I'd like to assemble something at, say, 1000, assemble. And then I can load accumulator A with the letter B. I could then store the accumulator in, say, string 1020. I could transfer A to B, etc., etc., etc. And just a return gets me out of that. And we could take a look at all kinds of things. Anyway, it's a nifty little program, and I think it's going to be a real aid to me as I learn 6800 assembly language. Next, we can take a look at the 2 other programs that are on this ROM, the side of the ROM anyway. Let's load TSC Micro Basic Plus. And there it is. This is a lightly patched version by Bob Applegate for his Corsham Technologies company. And he wanted to give the guys the credit, and as well they should have it. That's the TSC. Maybe it even should say by Bob Wiederwick. But, yeah, it's what it is. I also changed the prompt. I didn't like the exclamation point, so I changed it to a greater than sign. Slightly reminiscent of Apple I Basic, but what have you. This is an integer basic also. Dupes. Yep, does exactly what you'd think it would do. Next up, Tiny Basic. The familiar little colon prompt, and we can do all the same things that we would want to do with this, and in immediate mode works just fine. There you go. It's Tiny Basic. On the other side of the ROM, I have Altair Basic, and it's the only thing I have over there right now. I think I would like to reorganize my EEPROM, but for now, it's just sitting here, and all I have to do is tap the Z key, and it goes directly to a loader, puts it in memory, and then I can type G to get it going. Let's look at the Easter egg. Rick Weiland. Way to go, dude. This will give me exactly 16K of user memory. Your mileage may vary. You may want less. You may want more. Well, it's up to you. And it's basic. And it works pretty much exactly the way you would expect a basic done in late 1975, early 76 to work. This is very similar to Commodore Basic. Everything that was used in the PET is only one generation past this. So enjoy is what I say. You have many, many programs that you can use out of, the classic books, basic microcomputer games and more basic microcomputer games. There's all kinds of stuff on the web that this will run on. I've run all kinds of fun things that I did for the PAL 1 on this with very little modification. So that's a lot of fun, and those are some of the things you can do. However, there's only one real test of any 1970s inspired homemade computer, and that is, will it play Star Trek? Oh, hell yeah, it will. Let's play Space Voyage by Technical Systems Consultants. The TSC Space Voyage is almost identical to anything you would have played on a mini or mainframe in the 1970s. So all I got to do is load it. And as you can see there is a PDF of the instructions for this, and they are on my website. You can download this. You can have a blast with it yourself. And it loads pretty fast. Got a character delay of 5 milliseconds and a line delay of 30. So we're trucking along at about, 600 baud? Could be worse. Okay, that took just a little less than a minute. So, let's just do a quick little check here in memory and see what the program counter looks like. And that currently for me is located at F748. And it's 100. Well, page 1 anyway. And that's the start of the program. It's already loaded. All I got to do is type G and it will go to the program counter and we'll be running Space Voyage. Do I want a short or long mission? I would like a short mission, please. The password, this is for your self-destruct code, and my self-destruct code will be VIC, in honor of my first computer way back in 1982. All right, so I can get a short-range scan of the quadrant, and I can look at my long-range scans and see where there are Klingons and stuff. I can warp. Course 4, warp factor just 0.5. I just want to limp in there. Oh dear, something's going on. There's a Klingon in there, and the Enterprise is under attack. Oh my goodness. All the classic stuff. Shields, phasers, photon torpedoes. There is a teleporter. It's very interesting. So, let's take a quick look at the damage report. Nothing's damaged yet. Better raise the shields, though. You can see how this will play out. So, yeah, this passes my test for a real, honest-to-God 1970s home computer. I can play a version of Star Trek. Boom!
A full set of schematics, plans, drawings, parts lists is on my website. Everything you need to build your own Monster 68. And hey, have fun. Hack it, change it, make it your own. There's also software in terms of monitors and games and utilities. And, it's a great place to start. The 6800 world is not maybe as well known as the 6502 world as far as hobbyists go, but this is your chance to dive in and really get to know this interesting processor. Tons of interesting instructions and ways to do things that you just can't do on a 6502. All right, well, that's about it. I better wrap it up. So until we see each other again, take care.